As you might know, I sold my table saw and bought a brand new table saw. My old table saw had a router table in the wing. The new one has, well, it's got the table part of a router table. We just need to add the router part. So in this episode, that's what I'm going to be doing. I'm going to be building a new router table, not just putting a router in this existing one. Once again, thank you to Carbatec for helping me with my saw stop purchase and the mobile base they provided for me. In this video, I'll be pointing out the various Carbatec products that I'm using to build the router table, though they haven't provided any of that, so that part is not sponsored. They're just the things that I use anyway to build a router table. There are three things that we're going to be focusing on in this video: building the router table top, the cabinet, and the fence. The design of the cabinet and the top, more or less, is based on the new Yankee Workshops router table that they built many years ago. The fence is based on the works of Pat Warner, and I'll get into that a little bit more later. Router tables are pretty achievable cabinetry in my opinion. Even the fence, which is maybe a little bit more engineering, is pretty easy to make. You just need to allow yourself a little bit of wiggle room to dial things in. We're going to start with the router table top because that's easy enough to put to one side. The top is made out of 2 layers of 16mm MDF. The two halves are slightly oversized so they can be trimmed to final size after glue up. To help with glue up, I'm driving 2 screws into opposite corners. To do the actual glue up of the 2 panels, I'm using what's called a vacuum bag. By using atmospheric pressure, it's able to apply huge amounts of pressure very evenly. If you don't have a vacuum bag, there are probably 3 options. First, you could just buy 30mm or thicker MDF. Second, you could use a grid of screws to provide the clamping force needed. Third, you could just weigh it down. This is a little trickier as you need pressure to be as even as possible, but it can work. After coating the MDF in glue, the screws go back in so it doesn't slide around. Then the whole sandwich can be slid into the vacuum bag. This particular bag is a raw rocket kit. They're inexpensive, partially because they don't use a vacuum pump but this funky little valve. I use my shop vac to remove the majority of the air, then a hand pump can be used to remove the rest of the air. When it clicks like this, it's ready to bake for a while. After the glue is dried, it's removed from the bag and it's time to trim to size. And yes, the screws have been removed. The MDF makes up the majority of the table, but it will have a solid hardwood banding to make sure the MDF doesn't flake away on the edges. To aid with gluing the banding on, I'm adding dominoes. Yes, this is an expensive machine, but for this operation, you've got a lot of options. First of all, you could use nothing, as it's not strengthening the joint at all, it's just helping with alignment. You'll just need to be a bit % more careful. Or you could use a biscuit joiner or a brad nailer. Raw MDF and hardwood does not an attractive and durable tabletop make, so I'll be adding a layer of laminate. And even more importantly than that is a splash of green. Everything is just better in green. I've seen the score and snap method for sizing laminate, but that made me a little bit nervous. A track saw with a piece of MDF underneath worked great and with no chip out, and let me use familiar tools. When it comes to sizing the laminate, you want to have a little bit of overhang on all sides to make it easy to position when gluing on, but not so much that it runs the risk of snapping off and chipping out. I'm using Sika Contact Fix. It's a very stinky contact cement, but it was available from Bunnings. I have a paint tray lined with foil so it's easy to pour the contact cement into and then remove it later on. A cheap single-use roller provides a consistent, smooth application layer. Contact cement gets applied to both the backside of the laminate and the substrate. Both sides are left to dry, then they're brought together. This causes a chemical reaction that creates a very strong bond instantly, but it is very important to let it dry. After about 5 minutes, that's what this particular contact cement needs, it's dry to the touch and ready to go. If you're using a different product, check the manufacturer's instructions. Spaces are placed onto the MDFs, they won't stick, they don't have any glue on them, and the laminate is placed onto the spaces, giving me time to align it how I like. Then one spacer is removed at a time, and a J-roller is used to apply strong, even pressure. Start in the middle, then work your way to one edge, removing one spacer at a time. This ensures the two parts that you want to touch do and nothing else, and removes any air bubbles. After giving it a few hours, the laminate is ready for a trim. A flush trim bit in a router works great for this large panel. At the same time, I had also laminated some fence faces, which we'll get to later. They're far too small to use a handheld router to trim. At the table saw, I have an L fence, which is aligned with the outside of the blade. The MDF section rides up against the fence, while the laminate is trimmed away by the blade. I would have preferred to use a router table for this, but, well, you know. With the 2 layers of MDF, the hardwood on the outside framing it, and the laminate, this is very heavy now, and it's also very stiff, so it's perfect for our router tabletop. Problem is there's nowhere for the router to go. I've made a very nice table, but we need to put a hole in it so that we can put the router in. Now for the lift plate, I will be using this PRS 5000 from Craig. You can buy this at Carbatec. It's made by Jessam. Very nice piece of kit. It uses these little brackets here to hold it in. So we only need one big hole, and these brackets will screw into the underside, and they provide a way to lock it down and provide leveling screws built into it. Problem is we do need a fairly accurate opening to put the router into. I'm sure there's a dozen different ways to do this, but the 2 that I know of are basically just templating and how you approach the templating process. The absolute easiest way is to use a laser or CNC router to cut out a template. Then we can cut out the hole here, we'll roughly cut it with a jigsaw, and then flush trim it to the template. A much more accessible way is to place your router where you want, or router lift with its plate. Then we grab some scraps and some double-sided tape, and we can make our own template this way. This will then be an exact template of what we want to route away. And since this is tied up against the router plate itself, it's an exact template. So when we flush trim off these, it'll match this perfectly. The only issue you might see is these corners, which clearly this has a radius to it, whereas our template does not. These are 38mm diameter or 19mm radius corners. So your best bet is actually to drill it out first. We take our 38mm drill bit, Forstner bit in this case, press it up against the 2 guides and drill down. That'll give us that nice radius corner. To reduce the chance of any chip out of the laminate, I'm flipping the router tabletop, and I'm cutting from the underside. A standard jigsaw bit cuts on the upstroke, which, if the top was the right way up, would cause it to pull up on unsupported laminate. The other way around, it pulls down into the MDF. The 4 holes just need to be connected. The template is attached with double-sided tape, then the whole tabletop is flipped again. I'll be the first to admit I did a terrible job with the jigsaw and did not get anywhere near close enough to my lines. You should never have this much material to remove with the router and flush trim bit. I regret my life decisions. With the fit checked, the mounting brackets can be drilled and secured. They just need bog standard wood screws into the MDF with the lip pressed firmly into the corner. With a pilot hole, driving screws into MDF with a screwdriver by hand is pretty easy. I'm almost done with the top. We have the laminate, it's looking good. We've got the cutout for the router, it's nice and tight. I want to add a few more details before I can switch to focusing on the cabinet. First off, I want to add a mitre slot. Now, a mitre slot is just a slot that fits the standard 19mm or 3/4 inch mitre bar. This is what you'll find on mitre gauges, on various jigs like a box joint jig. The easiest way to do that though is just with a standard dado that will then fit this aluminium extrusion. The reason we go for the aluminium extrusion over just putting in a dado is that it just wears a lot better and it's going to run a lot smoother, particularly when you consider that this is MDF underneath it, and that's just going to be torn to shreds if we run a mitre gauge in it back and forth. We're going to start losing our accuracy as the MDF will eventually wear away. The extrusion is relatively inexpensive, though it will usually come in pieces longer than the router tabletop, so we'll need to cut this down. The good news with soft metals like aluminium is they can be cut with woodworking tools, so I've cut this to length on my mitre saw. Just be careful. I mean, you should absolutely be wearing safety glasses all the time in the workshop, but especially when cutting metals because those shards are very sharp and they will fly at you. The other thing that we'll need to add to the tabletop is the ability to have a fence. So we need to add some tracks for the fence to run in. That might get you thinking, why do we need to make a fence when we could just reuse the table saw fence? This is a good quality table saw fence. Surely it's good enough for a router. There's a few reasons that reusing the fence is not a great idea. The first to me is the killer, so we'll get that out of the way. If you reuse the table saw fence, that means it's shared between the table saw and the router table. Makes sense, right? Problem is, when you dial in a cut on the router table, you might then need to go back to the table saw to cut a piece down as you're dialing in the fit, and that means you need to bounce back and forth between the two, and you'll never get that dialed in result. Having a separate fence means that you're not having to make any compromises between what tool you can use at any one time. The other reasons are important, but they're not quite as show-stopping as not being able to use my table saw. If you use the table saw fence, you won't have any dust collection. You won't be able to embed the bit so that only part of the cutter is being exposed. So the solution to that is to build something that cradles the fence. And I've done that in the past and it works fine. But again, the big issue is that you can't use both tools at the same time without losing settings. And for me, that is non-negotiable. So with that out of the way, we need to have some sort of mechanism where a fence can ride back and forth. I'll be using aluminium extrusion. This is T-Track. It is almost the same as Mitre Track. You could probably use Mitre Track, but this is smaller and cheaper, and it does the job. You can see the size difference. In fact, the T-Track will fit inside the Mitre Track. Just like with the Mitre Track, the T-Track will get a groove for it to sit in, but because it is a stopped cut rather than all the way through, we'll need to do this with our plunge router and an edge guide. But first, let's get the Mitre Track in. For whatever reason, I goofed up and cut slightly to the right of my line, resulting in a slightly gappy dado. Annoying, but not the end of the world. As you can see, that this piece of T-Track is not as long as the entire router tabletop, so we'll be doing a stopped dado for that, or stopped groove. So to do that, we'll be using the plunge router, as well as an edge guide on the plunge router. The edge guide will provide a nice stable platform so that we're consistently making straight lines. This piece of plywood here that's clamped to the tabletop is to stop my router from going any further than where I want it to. Now when we do those multiple passes, first we'll do a pass on the right hand side and then on the left hand side. Then the fence will be adjusted and then we can go to the left hand side, right hand side, it doesn't really matter. The idea is that you'll do a pass on both sides and then make the adjustment. That way you are only making the adjustment once to widen both tracks. When we're making these dado passes, we travel from left to right, and when we make the adjustments with the fence, we're moving the cutter inward, so adjusting the fence out, I suppose, so that the cutter can go more towards the middle. You'll see what I mean in a moment. I first start with a very shallow pass to clear the laminate. It turns out it's very tough stuff. Take a couple of passes to reach full depth. After the first pass to full depth is complete, the fence is adjusted over to be close to my line. I really want to sneak up on this fit. A short test cut to check the fit. As it doesn't fit yet, another small adjustment is made. The router bit leaves rounded corners, so I could round the track, or square the dado, or just leave a gap. I opted to square the dado. Laminate can be chopped into with a chisel, but it's tough going. Take very small passes so you don't crack the laminate. And with that, the last part of the top is done for now. Onto the cabinet. The cabinet is made from 18mm pine plywood, the same stuff I used in my Dutch tool chest. If you're not sure about plywood grades and how best to break it down, I encourage you to watch that video where I cover the topic in detail. Nearly all of the joinery is screws in dados. I took a little bit of extra time to dial in the exact width with my dado stack to get to 18mm. It was the 2 outside blades, 3 chippers, 1 spacer and a couple of the included shims. For a project like this with many dados, it can be worth the time figuring out the exact size. While I'm following the placement from my plans, the exact placement of the dados isn't the priority here. The important thing is to have things the same on the opposing pieces and symmetrical where applicable. Make all of the dados from a common edge before adjusting the fence, flipping the pieces if it makes sense for mirroring. I have the router table all mocked up. It's just dry fit and a couple of clamps to check the dados to fit all of that. And as you might be able to see, I have very accurately incorrectly cut these dividers here. By very accurately, I mean they are exactly what I meant to cut according to this sheet here. Unfortunately, this sheet here is not correct. I measured from the wrong side of a notch. This piece here, this front stretcher, is supposed to go on top. So these are 18mm short. And the downside is that means that any dust in the middle here captured by the router table will spill over into these dividers. So I have to make these again. What I'm going to do is take a offcut and my board stretcher, that is domino, and just glue on some extra bits to make up the difference because this is not an appearance grade project. So I'll rip this down, add in some dominoes, glue it up, and then cut it to the correct size this time around, and then be able to proceed from there. The 2 small dividers need a notch to accommodate the front stretcher. This is 75mm wide, so this notch needs to start at 75mm. I'll cut the long section of it at the bandsaw, but here at the table saw I can cut a nice reference mark for it. I have it clamped to my mitre gauge, and I've got a stop here that is a known distance, so this is an 18mm scrap, so that I don't have any issues binding. Shouldn't really be any issues as it's a non-through cut, but better to be safe than sorry. Just remember to allow for the kerf of the blade, so I've measured 75mm minus the kerf of the blade, 1/8 of an inch, and then added on the thickness of the stop to get my exact location. I want to have some integrated dust collection, so I'll be using this piece of PVC pipe. So this is 2 elbows, and I've 3D printed a flange to mount it. I want this mounted underneath, so this will be at the back of the router, so hopefully it'll draw everything down using some gravity and some suction and draw all the dust out of the cabinet. I'll have the hook up for it on the side of the cabinet, so this means this drawer here is going to be a little bit shallow. Actually, it's going to go this way, so this drawer won't be able to be as full depth. I also have to cut the divider that's between these 2 sections down a little bit to accommodate. In the long run, you'll see why this hopefully is going to be beneficial, but what that means is I need to cut the hole for this now while I still have access to everything before we do any sort of glue up. Pilot holes are drilled so that the jigsaw has somewhere to enter. It also makes it a bit easier having multiple holes so I can cut from different angles without having to worry about twisting my hands too much. The inside of the flange is lined up with the initial circle, then screwed down. The plywood can be flipped so a bottom bearing flush trim bit can be used on the flange. The results are really good, though unfortunately the flange is mounted to the wrong side, so it needed to be unscrewed. The hole gets a heavy chamfer to encourage dust to flow down there. I have the cabinet dry fit together. We can see that the lower divider here doesn't go all the way because of the dust fitting. I've also printed another flange here, and you can see the pipe goes from the opening that we just cut through to the side here, and this is where the ducting will connect to. So now I can do the exact same process of tracing this flange, cutting it out, routing it flush with it, and then the internal dust collection will be done. From here I can also mark this lower divider where that needs to sit so I can cut it down to size. After doing a dry fit, I've noticed this dado here isn't quite at full depth just in this last little section here. So the plywood must have just lifted up slightly, maybe it wasn't perfectly flat when I was cutting the dado. I've got two options. I could go back to the table saw and recut this dado, though getting that alignment right and dialing everything in perfect, it's going to take a bit of time. This is why you kind of want to get things right the first time around. A great alternative is using a router plane if you have one. I can just come in here and gently nibble away at those little parts that are a little bit too high, and then I'll have a perfect fit. I've set my blade height to the other end of the dado, which I know is correct, and then as I scrape along, it just starts taking small shavings off. Really pleased with how this has come out. The flange allows such an accurate hole to be copied, so the pipe fits super well. Now you're probably thinking one of two things, either, wow Paul, you're so handsome, or wow, that's a lot of 3D printed parts. I don't have a 3D printer. Can I just not make a router table? To which I would have to say, thank you. I've been told I look like Hugh Jackman, which is very weird, but thank you. Also, 3D printers are just a tool. I'm using a 3D printer here, but if you have a laser or a CNC, you can cut accurate circle hole templates very easily. If you don't have those, you might have a friend who has a CNC laser or a 3D printer, or a lot of local libraries these days have 3D printers. There are also online services where you can order these files printed for you, or you can just go to the store and get a PVC flange. These are just standard dust waste vent pipes that I'm using. I can't drive for medical reasons, so I can't as easily go to the store and pick up a flange, but it is pretty easy for me to print a flange at home. So it's just a means to an end. Having a 3D printer is not important for woodworking. A few of the parts, namely the two side pieces and the base of it, need to have a rebate to accept the back panel. My tool of choice for making rebates is the router table. So with no router table to make the rebates, we're going to be using the table saw. There are a couple of ways we can do this. First would be setting your fence nice and wide and using your dado stack with the exact width to cut your rebate. Now this is not the greatest because you can have the fence out quite a long way for quite a small rebate. And if you have different size parts, you then have to make lots of adjustments for the exact same size rebate, which is there's a lot of faffing around. Best solution, in my opinion, is to have the fence close, then use a sacrificial fence. Sacrificial fence is just a piece of MDF in this case. It's got two holes drilled in it. I'm using these Carbatec clamps, fence clamps, to hold it to my fence. And then I will move this sacrificial fence over the dado stack. So we only need it to have a little bit of the blade embedded into the fence, and then we'll have a zero clearance dado stack, and we can vary the position of the fence to vary the width of our dado. This is a brand new sacrificial fence, so it has no cut in it. So how do we get that? Well, we clamp it all down and then we turn on the saw and slowly raise it up to where we want it to be. You see the blade there? So we want to bring our fence across to that. I'll lower it back down. And in this case, I only want to go a little bit further over, then I can lock it down. A couple of test passes later, and that is a very nice fitting rebate, at least in the width of the rebate, so that's moving the fence over. Now I need to worry about the height. I want to go for about half this material, so around about 9mm. So this is set to 9mm, and I just have to raise my blade to that height. If I take my calipers and measure what's left behind, I get pretty much bang on 9mm, just under. This is 18mm material, so I know that that's roughly half, and that fit looks pretty good. It's certainly going to be more than good enough for a router table, so now I just need to put this on those 3 pieces I mentioned before. While I have the dado stack out, I'm adding dados to the 2 sides and to the 2 upper dividers for bit trays. Because the parts are different sizes, I'm measuring from the top of the part down for the dado. The dado is only 12mm wide by design, as at this point I didn't know what material I was using for the tray bases. Over the last few minutes I've been slowly adding screws. I'm using these quite large Conformat screws once again, striking a line across, spacing it out fairly evenly. The advantage of using screws rather than just glue and clamps is that I can take my time, get everything really dialed in so it's really nice and flush on the front, screw it in, make sure it looks all good, and if I choose to I can unscrew it, add glue, put the screws back in, and I won't need any clamps. Clamps at the moment hold the wood very tight in the dados, which means that the screws are getting as much clamping force as possible so that this might not even need glue. Working my way 1 screw at a time, working my way down the line. Doing it this way means that everything will conform to where the clamp is and it shouldn't have any buckling or anything like that going on. With that assembled, even before I have the back attached, it's starting to get pretty heavy, so I've added these leveling casters. Because this is going to go in the table saw wing and it needs to match the height of the table saw, I need a way to level it, but it'd also be really nice if I could move it around from time to time. The leveling part gets it off the wheels and the wheels make it move around. There are at least more than 2 ways to make a drawer. Some ways will be based on the materials you use, some will be for the aesthetic, I suppose, of the drawer and how pretty it looks. But when we're talking about utility drawers, it honestly doesn't matter. You could use a quarter method, you could dovetail them, you could box join them, but I'm just going to screw them together because for this purpose, for the type of use it's going to see, it's going to be more than enough. First, we need to be able to size our drawers. Now you might think I just have to take the opening here and that's the size of my drawer, and you're not far off, but you do need to take into account the drawer slides. So in this case, I'm using full extension ball bearing drawer slides and they're side mount. If you're using undermount type, obviously all you need to measure is this space here plus a little bit of a gap. In the case of these side mount ones, we can stack the 2 of them up like that, 1 on each side, and measure to the far edge here, and that's how wide our drawer can be. But that's the outside of the box, and we need to think about how the drawer is actually going to be constructed. The drawer will have a base. This is the length of the drawer. Width of the drawer is in the opening up the top here, minus the thickness of the material by 2. So it's 15mm material. We then have a front and a back. They're both the same size pieces, and you can see here that they're the same width of this base. Then we have 2 side pieces, 1 on either side, and they are the length of the base plus 2 times this material, so they're an extra 30mm longer. Screws will go in through the front here and through the side, and the same across the back here. That'll provide a really rigid box that it's pretty basic, but it'll do the job. Then if I want to, I can put a false front on like so, maybe not this big, and this is where the handle will be attached to. By putting the false front over the top, you won't see any of the front here and you won't see any of the screw holes. Not that it's a big deal, again, for this utility, but it does hide a lot of the ugliness of this type of box. Drawer slides come in 2 parts, the cabinet side and the drawer side. To align the drawer side, I use a block clamped to the front and just butt it up against it. On the cabinet side, I use a spacer to position the drawer slides away from each other. The fixed portion of the drawer slide gets lined up with the front edge of the plywood. With the spacers removed, the 2 drawer parts are just pushed together. These Hafal drawer slides need a little bit of convincing to self-align. The bit trays don't get any fancy drawer slides, but simply rebates to fit into the dados cut earlier. It's a good thing I have this sacrificial fence now. The drawer faces just get tacked in place with headless pins, then screwed in from the back. The pins are just secure enough to open the drawer, but easy enough to pull out for painting later on. The door is just like the drawer fronts, a simple single piece of plywood. The hinges need a 35mm hole drilled in the back side of the door. the hinges around, so it is easy to have them out of alignment. I find the easiest way to keep them square is to pop them in with something straight and square going across them. Square that up and they'll both be aligned. I have one of the bit drill front faces here. Before I glue it on, I'm going to drill a hole for the hardware. This is a 4mm drill bit. Then later on I'll be able to add the M4 bolt with no issue. This will just receive a little bit of glue in the dado and then be clamped together. It's not a high stress joint, and if it fails I can always screw it together. I've got little marks here for where it's going to line up with the drawer so it lines up with the cabinet. Now I can clamp that together and come back in an hour. I want the power lead from the router to go out the side of the cabinet to the switch I'll mount on the right hand side. A 44mm hole is drilled to allow a standard Australian plug through. On the side of the cabinet I've added this little bracket here that allows me to attach my safety switch. Australian socket plug just goes in there. This type of switch doesn't require any electrical know-how how to use to attach it to anything. The face, as you can see, pops off quite easily. There's just a couple of screws that hold it on, and then a couple of bolts that go through the back to hold it to my little bracket. So now I can just screw this back together and it's good to go. With the plug and cable poking through, I don't want these large holes because dust will get in or out. So I've made two of these little covers. The inside one's a little bit harder to show off on camera, so this will just straddle the cable like so and can screw in and close that off. I've wheeled the router table and its top into place. I've had to remove the old extension table, came with the saw, and its legs, and it's a good thing I did just get a new saw and calibrated all of that because I had to move the fence rail out of the way as well to get to some of the screws. Doesn't really matter. I don't need these legs now because any support or any material that's going to be on this end where you'd have the most leverage is going to be on the router table, which is connected all the way to the ground through the feet in the cabinet. I don't need them. They're not providing any additional support. But it's really nice to see this in its place. So it's a very tight fit, but you can get the general idea. Oh, that's extremely tight. There we go. So if I ever had the situation where the dust pipe was in the way, or I needed to cut a wider piece, or whatever it is, I can move the router table back and forth. It is more or less fully independent, but also is very compact and can go away in the table saw. The top is not attached yet, so that is the next task, and then we can finally get onto the fence. So I'm going to do a little bit of a spoiler here and reveal the router table fence before we actually get to the building of it, because it is a relatively complex part. And, well, frankly, there's a lot going on that will make sense when you know what you're building towards. This design is based on one by Pat Warner. Pat Warner passed away around 2019, and unfortunately his website has gone offline, so finding some of the information is a little bit tricky, but there's an article on either Fine Woodworking or Popular Woodworking from 2002, which shows off this type of design. Though it is made from different materials, Pat used a bunch of hardwoods. I've gone for MDF, aluminium, and some 3D printed parts, and it conveys much the same intent as Pat's design with just a very versatile, accurate fence. Got a piece of MDF with laminate on it for a nice durable surface. Behind that is some 2080 Maker Rail or V-Rail. It's aluminium extrusion, relatively inexpensive, and gives us a dimensionally stable base to have all our fence faces on. Behind that is some aluminium square hollow section. So this is 50 by 50 aluminium, which is again very dimensionally stable, gives us a nice solid connection between all our parts. Then you've got the carrier piece of MDF and the base piece of MDF. Now why do I call it the carrier piece and the base? Well, the base piece, it's on the base, but the carrier piece, if we loosen these knobs here, allows us to move the entire fence face on this with this micro adjuster because of these aluminium flat bars that will act as tracks. Here there is a dial indicator, which means that we can track how far we're doing this micro adjusting. The fence is a sandwich of parts. First is the base plate and the carrier or moving piece, both made from MDF that will have aluminium flat bar between them to act as slides. Both pieces get matching dados cut at the same time to accept the aluminium. The flat bar is 25mm wide, so it's a fit I need to sneak up on. It is very deliberately a tight fit, though perhaps it didn't need to be this tight. The flat bar is attached to the base plate with some wood screws. The carrier piece is just placed over the flat bar and rides on it. It's restricted to move on one axis only. The linear motion that the flat bar provides will allow me to make a micro adjuster. Another piece of flat bar is drilled for an M8 thread and 2 wood screws. This piece will end up on the carrier board. With the thread tap in the chuck, it's manually rotated to get a couple of starter threads, which should hopefully be square, making hand tapping easier. A standard M8 bolt will provide 1.25mm of travel per full rotation, which might sound like a lot or a bit of a weird number for a micro adjuster, but adding a dial indicator later on will take care of that. The threaded block will be attached to a block of wood that will then be attached to the carrier piece. There will be a separate wood block on the base that will line up and have a bolt run through it, but it has no threading or other attachments. With the flat bar unscrewed, I can make a through hole. This is larger than the M8 bolt. The underside of the carrier gets pilot holes drilled to mount the block. If I was to make one change, I'd use bolts here rather than wood screws. This piece here needs to get drilled and tamped for M5 screws to mount it to the MDF, as well as through holes for other M5 bolts to attach it to the aluminium extrusion subfence. For the holes that will get tapped with an M5 thread, I'm using a 4mm drill bit. Ideally you want a 4.2mm drill bit for threading M5, but because aluminium is pretty soft, 4mm is fine. Next up is a superfine chamfer just to ease the hole. You might be wondering why I have a super large tap handle. I bought it for tapping 3/4 inch threads in brass, which honestly I prefer over tapping these tiny delicate threads that are hard to balance. We need to attach this extrusion to this square box section. To do that, I'll be using some small M5 screws and these T-nuts that go into this type of extrusion, so slide in like so. So we need 2 holes per bolt. So we need one that goes through the aluminium like so and attaches into the extrusion, and we also need an access hole that'll be a little bit larger so that we can actually screw it in with an Allen key. So while we've got it like this, I can mark out with a marker where I need to drill, at least vertically. So I need one there, and I'll have 3. So I'll have 2 in the lower position and 1 in the upper position. Might also notice I've got a couple of 1mm spacers. These are just plastic spacers, shims, because I don't want the aluminium dragging on the tabletop. So having just a hair gap there will be actually quite a good thing. The head of the bolt is about 7.5mm, so I've got an 8.5mm drill bit. I'll drill through this hole and it will just touch the other side. That'll give us a nice starting location for a small bit just for the threaded section. See, the nuts and bolts are all through those holes. I can access them through the backside here. It's a little hard to do that on camera, but for the moment of truth, does it slide on? These are very fiddly, but it does slide on. I can now lock that down and I'll have a nice secure connection between these two parts. One benefit of doing it this way is, should this piece be out of square, tilted relative to the table, I can always shim between one of these 3 points and adjust the square of the fence. To attach the square section to the carrier plate, the underside of the carrier gets a counterbore and a through hole. The through hole is 6mm for the 5mm thread to give just a little bit of adjustment room. I need a way to lock the two halves of the fence together, but still allow them to slide back and forth when I'm making those micro adjustments. The easiest way, honestly, is to just have another T-bolt. The head of it can be embedded in the bottom half, and there'll be a slot rather than just a hole in the top half. To get the placement right, I've got them both stacked together here at the drill press, and I'll drill a pilot hole through that'll give me the location on the bottom of the bottom piece where I can make the recess for the head of the T-bolt. We have our pilot hole, and I'm going to drill just to the left and to the right to create 2 overlapping holes. These T-bolts are about 12mm wide and about 16mm long, so long as it can't do a full rotation, it'll tighten down just fine. So I need to just make a very shallow hole, just deep enough for the head on one side of the pilot hole and then on the other side. With the fence now flipped back over to the correct side, I've got a 5/16 inch bit for the T-bolt to go through. We can drill all the way through now. And the same can happen on the top piece. I can pop the bolt through and secure it. As I tighten it down, it doesn't spin because of the recess we've just cut. Now I can cut this circle. This cutout in both fence bases is to allow larger bits to be embedded in the fence for when I only need part of it exposed, either for safety or just because I don't need a full cutter. It's a rough cut, but it'll be completely invisible. The aluminium extrusion needs a hole cut for the router bit to come through. This could be cut on the bandsaw, but I'm not interested in ruining my expensive blade, so instead I used a jigsaw. This square notch is about 60mm tall, leaving 20mm completely untouched. On the carrier piece, it gets an open-ended slot. The bandsaw is great to connect up with the drilled hole. I don't have the ideal size machine screws on hand for the fence faces. I'd really want something like an M5x22mm, but the longest I have is M5x16. To compensate, I'm counterboring, then countersinking. With all of the holes drilled, it's assembly time. On the base, the aluminium tracks, micro adjuster and lock knobs are already installed. On the carrier, the aluminium extrusion and box section is already attached. 2 nuts jammed together keep the micro adjuster from screwing in and out of the block, instead making the carrier piece move back and forth. The last thing to add, don't worry, I don't believe myself either, on the fence is a little block so I can mount a dial indicator. Dial indicator with that micro adjust means that we can really accurately adjust the fence. So this little block has been drilled and tapped for M6, which is the bolt that came with this was M6, so I may as well reuse that. I just need to attach this to the base plate so that the dial indicator will press up against the square hollow section aluminium. I think this spot here is probably as good as any. Then the dial indicator came with this M6 bolt, goes through the mounting hole, and I need to find a Allen key. There we go. Going to set the dial indicator to 0. Piece of tape on our knob here, so one full rotation should be 1.25mm. If we rotate it a little bit, we get a bit of movement. Full rotation, yeah, that's pretty close. There's a bit of slop in the mechanism, but it still should be measurable, and that works pretty well. Then I can lock it down. There's a little bit of movement from the locking mechanism, so we probably want a washer underneath so it doesn't rotate things. But otherwise it's quite a fine controlled adjustable fence mechanism. As I said, I wouldn't trust me that it was the last thing I needed to add because I need to add some more dust fittings. So this is for a shop vac. Eventually it'll be hooked up to my dust collector, but for now I need to order in some extra spiral duct things. This is going to get duct taped on rather than hot glued in, and I need to duct tape these access holes up too. So I'm just going to put some tape over, and then air's not going to flow out of there. Shockingly, I don't have any green tape. I attached the tabletop to the cabinet with just 2 screws from the cabinet. It's so tight in with the table saw rails that it's not going anywhere. I hot glued in the bit holder trays. Now I can store all my bits in these convenient little drawers. I even managed to find some green tape that matches. That's very exciting for me. So there's nothing really left to do other than give this a test run. So I've got a piece of plywood here. I'm going to put a rebate on it, and then I'm going to make it a 5mm rebate by using the micro adjuster. So I've set it to whatever. Let's see how it goes. Get out my calipers. Let's see what that rebate is. It is 5.11. You know, that's not absolutely perfect, but for what I was aiming for, 5mm, that's pretty darn good for the first time using this fence. So a little bit of play in it that I just need to work out, maybe tighten down that nut. It's a lot more accurate and easier to adjust than my previous router tables fences, so I'm very pleased with that. I'm also very pleased with just the router table in general. It is a little bit quieter than it was before. It's greener, and that's a very important thing to me. This surface will be nice and hard wearing. I've got a lot of flexibility in everything. The fence is more accurate, it's easier to adjust, it's got more features in it. In the description below you'll find links to a lot of the products that I've used to build this, as well as all the print files. The print files are a collection of parts that I've designed, as well as those that I've found online, and they are all available free in the link below. Thanks for watching.